Question 1, oxidation state of chlorine. We are supposed to find the oxidation states of chlorine inside here, here, and here. So we know that the total oxidation state, when we sum them up for this compound, is -1 based on the charge here. And we know that oxygen usually in a compound is -2. So we have -2 here. The total is -1. That means the chlorine here should be +1, so that when we add them up, it gives us a total of -1. Using the same idea, we know that the total oxidation states, or the sum of the oxidation states for this compound, is -1. There are 3 oxygen, so -2, -2, -2, -6. The oxygen is -6, the chlorine will have to be +5. So that when we sum them up, we get a -1 overall. So essentially, we are using oxygen to help us find out what the chlorine's oxidation state is. Finally, we have Cl-, charge -1. So oxidation state is also -1 here. So we have +1, +5, and -1 for the chlorine. That gives us D. Oh, sorry, that gives us C. Question 2. Combustion of methane and ethane under excess oxygen. So what happens when they burn methane and ethane, the hydrocarbons? When they burn, they give us carbon dioxide and water. And after burning, they tell us that the gas was passed through aqueous potassium hydroxide. What actually happens is we have carbon dioxide, which is acidic. After passing through aqueous potassium hydroxide, the carbon dioxide will be removed. Right, so when they ask what volume of gas was absorbed by the alkali, they are asking actually how much carbon dioxide was produced in the first place when we burn 10 cubic centimeters of ethane and 10 cubic centimeters of methane. So we start off with a balanced equation. I'll use the space on top. Methane, CH4, carbon dioxide, water. We have 1 carbon, we have 4 hydrogen, and then when we balance the oxygen, we have 4 on that side, we have to have 2 here. So doing the same for ethane, carbon dioxide and water, 2 carbons, so 2, 6 hydrogen, 3 times 2. Total we have 7 oxygen, 4, 3, so we need 7 over 2 to make it 7 oxygen on the left side. Right, now we need to find out how much carbon dioxide was produced in these 2 equations. So using the information here, 10 cubic centimeters for methane, and then by ratio 1:1, we will also have 10 cubic centimeters of carbon dioxide just from the methane. For the ethane, 10, that will give us 20 carbon dioxide from the ethane, and then all we have to do is add them up, 10 and 20, so the total carbon dioxide that was absorbed by the alkali eventually will be 30 cubic centimeters. Question 3 is on electrolysis of aluminium oxide, extraction of aluminium. So a quick recap on the concepts involved before we go to the options. We have the graphite anode and the graphite that's a cathode. Now it will be useful to remember the anode, oxidation takes place at the anode, and for the cathode it will be reduction. right? So what happens is in the electrolyte we have Al3+ and oxide ions, and they will migrate to the respective electrodes. So for aluminium 3+, it will go to the cathode, and then it will gain 3 electrons, form aluminium. For the oxide, it will go to the anode, where it will form oxygen gas. Right, keeping this in mind, we look at our options now. Option A, aluminium ions are oxidized in the process. Well, if you look at the equation, aluminium ions are actually being reduced. They gain electrons. Gaining electrons is reduction. So option A is not correct. B, aluminium is liberated at the anode. Aluminium is actually liberated or created at the cathode. So B is wrong. Cryolite is purified aluminum oxide. No, cryolite is actually a compound of aluminium that's thrown into the electrolyte to lower the melting point and to allow the electrolysis to be carried out at a lower temperature. It's not pure aluminum oxide. Nope. So D is correct. The graphite anode burns away. I'll explain what's happening here. Remember that we get oxygen being produced at the anode, and we have the graphite being the material for the anode. So what happens? The graphite, which is actually carbon, and the oxygen that is produced under the high temperature and all that, we will expect it to become carbon dioxide. We expect them to form carbon dioxide. So eventually we have the solid graphite being burnt away literally by the oxygen and released as carbon dioxide gas. So D is the correct option.